Well, here we are again. I think this is the eighth video. I'm not really sure. I've lost count. Eight, nine, maybe ninth. I don't know. Originally, I planned on doing one video a week, but it looks like it's turned into one a day. I'm sure I'll slow down at some point. But I'm kind of enjoying it, even though it's really cringy to watch these videos after I've recorded them because it's so terrible. I'm still enjoying doing it. So, if you're new to the channel, just let me say that these videos are designed to be like a whole series. And so each one builds on the one before. So they're not meant to be taken in isolation. To really get the drift of what I'm saying, you might have to watch the whole thing. But you don't have to if you don't want to. So right now we're talking about epistemology, and I'm talking about various different ways that we know things, different methods and different sources we have for information that goes into our heads. And today we are talking about inductive reasoning. Inductive reasoning is a less certain way of knowing things than deductive reasoning, because in deductive reasoning, as long as your premises are true and your conclusion follows logically from the premises, then your conclusion cannot fail to be true. But with inductive reasoning, you can't get that kind of certainty. The best you can get is probability. And so there's always a little bit of room for doubt. I guess one of the ways that people describe inductive reasoning is to contrast it with deductive reasoning. In deductive reasoning, you reason from the general to the specific. All men are mortal is a general statement. Socrates is a man is a example of all men, and therefore Socrates is mortal. That's a very specific statement about Socrates that's deduced from the general premise that all men are mortal. Inductive reasoning, it's the other way around. You reason from the specific to the general. So, for example, every time you get near a fire that happens to be hot, you form the generalization, well, it must be the case that all fire is hot. And so you're reasoning from the specific to the general. And the reason it's uncertain is because unless you actually experience every single fire that has ever existed, you're never 100% guaranteed that every fire is going to be hot. So the principle of induction kind of relies on what's called a uniformity of nature. The idea that the laws of nature are constant. They just stay the same. And so if it's always been the case that nature behaved a certain way in the past, then you just assume that it's always going to behave that way in the future. Or if you're performing an experiment in the lab to find out how a certain part of the nature behaves, like maybe the behavior of an electron or the behavior of a beam of light, the double slit experiment, you find out that, you shoot a beam of light through a double slit, it forms this interference pattern. So you assume, well, that's just the way light behaves, even if you're not in the lab, Light everywhere is a wave or something, or electrons everywhere behave a certain way. So you're extrapolating from your experiences, your direct, immediate experiences, to outside of your experiences. So, but this principle that the future will resemble the past, or that nature behaves the same way outside the lab as it is in the lab, that cannot be proved. And the temptation might be to say, well, look how successful science has been. We've performed all these experiments in the past, and it's always yielded results. Experience has been a good teacher. So since it's always worked in the past, I guess the principle has been proven to be true. Well, that's circular reasoning. It's obviously circular reasoning, because you're using the principle, you're assuming that the principle is true in order to prove that the principle is true. And that's circular reasoning. David Hume talked about that in a couple of his books. One of them is called An Inquiry Concerning Human Understanding. So this idea that the future will resemble the past, or that nature is uniform, or whatever, is not something that can be proved. Yet So it belongs in our foundation. The way we know that is through a rational intuition. It's just something that's hardwired into us, just like our knowledge of the external world, our knowledge of other minds and everything. This is just another one of those things that can't be proved, and yet is obviously more reasonable to affirm than to deny. It would be crazy to think gravity is just going to stop working tomorrow, or to be 50-50 on whether gravity is going to work tomorrow. We reason that, well, gravity has always worked a certain way in the past. I've always weighed a certain, well, I haven't always weighed the same amount, but gravity has always worked in the past in a uniform way, and so we assume, well, it's just going to keep working tomorrow. And if you think about it, everything you learn from experience, you're using this principle. Fire is hot, water boils at a certain temperature. The way people behave, I mean, you kind of apply this principle. You see patterns of behavior. If you meet a dishonest person, they're consistently dishonest, well, you expect they're just going to keep being dishonest, so you don't trust them. But if they've proven themselves to be honest and reliable, well, then you assume they're going to be honest and reliable in the future. Now, this is a less than certain knowledge, because it's always possible that in the future things will be different or whatever. With each of these different methods of knowledge that I've been talking about, there are fallacies associated with them, or mistakes that you can make when applying them. I didn't mention this in the last video when I was talking about the external world, but the problem there is the possibility that you're having a hallucination or you're dreaming. There are cases where your senses can deceive you, but we nevertheless trust in the general reliability of our sensory perceptions to give us true information about a real external world. So the fallacy in the case of using inductive reasoning is hasty generalization. And that's where you form a generalization based on a sample size that's too small to justify making that generalization. Now, how big your sample size has to be in order to form a generalization is a matter of controversy. You can use statistics if you want. If you perform some experiment, or you perform some action and you see some result, and the result always happens 60% of the time it comes out one way, and 40% of the time it comes out another way, and you do this like a gazillion times, then you assume there must be a 60% chance that the next time I do this, that you're going to get that result or whatever. But not everything can be parsed out that way. And another problem, another difficulty with reasoning inductively is I forget the term, but it's basically you have to compare like things to like things. And so reference class, there's a problem of reference class. So for example, say every barber I've met has had a good sense of humor. And so I assume that all barbers have a good sense of humor. But what if somebody comes along and says, well, now that may be true, Sam, but every barber you've met has had a mustache. You haven't met a barber without a mustache. So you can't reason that all barbers have a good sense of humor, because maybe the ones without mustaches don't have a good sense of humor. Well, then you have to argue about whether having a mustache or not having a mustache is even relevant to the question of whether somebody has a good sense of humor. So there is a problem of reference class, and whether making exceptions or whatever are relevant, whether you're talking about the right reference class. What if all barbers I've met have happened to be men, but I know that there are women barbers? So could I reason that because every barber I've met has had a good sense of humor, that therefore even the women have a good sense of humor? Maybe, maybe not. Maybe there's no difference between male and female as far as sense of humor is concerned. It doesn't make a difference. Maybe it does. I don't know. You have to go somewhere else for that. So there's always a measure of uncertainty. Crows, the typical thing that people bring up is crows. Every crow I've ever witnessed has been black, therefore all crows are black. Well, I've only witnessed crows in North America. I've never witnessed a crow in South America. So how do I know crows in South America are black? Well, why should location make a difference? I mean, obviously, in any case of reasoning from specific things to general principles, there's always going to be some difference. And I mean, at the very least, the difference is there are things you haven't observed and things you have observed. So something you haven't observed, it's going to be different. It wasn't located where you were looking at the time or something like that. You can always point out some difference. The big question is whether it's a relevant difference or not. And that is always going to be a little bit debatable. So I guess that's all I had to say about inductive reasoning. So next time we'll talk about a few other ways of knowing. I still have a few things to go. I wanted to add one more thing to this video, which is the fact that this built-in knowledge we have that the future will resemble the past. It applies to animals as well, cats and dogs. That's how you're able to train your dog. If you give your dog a treat every time it does something right, it expects the next time it does something right that it will get a treat. And cats, almost all animals, learn from experience. Everything that you learn from experience depends on this principle. Science depends on this principle. And so it's crazy to deny it just because you can't prove it.